All right. So thank you for joining us today. This is our third wildfire webinar of the year. This program is supported by funding from Calfire through their wildfire prevention grant program that was awarded to the VCRCD in December of 2024. Our wildfire webinar occurs quarterly, and you can join our monthly newsletter or follow us on Instagram to be informed about future events and programs. And I will put those in the chat when I'm done giving my intro for you guys. My name is Heidi Ortloff. I am the Education and Outreach Coordinator at the Ventura County Resource Conservation District, the VCRCD. It's a state special district that serves the Ventura County region. With me, I have Joelene Tamm and Kim Corella, and you guys can correct me if I said any of those wrong. And our presentation today will be focused on the recent discovery of the invasive gold-spotted oak borer, or GSOB. It was recently discovered in Simi Valley, and it is a threat to Ventura County's iconic oak woodlands. This presentation will explore the biology of GSOB, how to identify it, and how its devastating impacts directly increase local wildfire risk. And we will be looking at practical solutions, and attendees will learn tools on how, like prescribed fire, strategic thinning, and community-wide planning to combat GSOB while creating healthier, more fire-resilient forests for everyone. So I want to thank you guys all for joining us today. You can introduce yourself in the chat if you're a concerned resident or if you're with a organization. That way we just kind of know who's in the audience, and we can kind of predict and like tailor any information we have to share for you guys. And with that, Joelene is here with us today. She was going to be our speaker. She's having some voice difficulties at the moment. So Kim will be doing the bulk of the presentation, but Joelene will also be here to answer any questions. So Kim, are you ready to take it away?
Yes, let me share my screen. Hold on one second here. Oops. I'm getting there. Hold on.
And just so you know, Kim, someone put in the chat that they're new to Ventura County, and so hoping to learn about this threat.
Oh, great.
Great.
Perfect.
Yeah, that's great information.
Yeah. Can you guys see that okay?
I do not see your screen yet.
Oh.
Now I see it.
I see it. Okay. All right, perfect. So thank you everybody for joining and your interest in GSOB. And as Heidi mentioned, I'm presenting for Joelene. And so today we'll be talking about GSOB and wildfire resistance in Ventura County. And we'll go over a lot of different aspects of GSOB. So we'll begin. So GSOB was recently discovered in Simi Valley. And by GSOB, I mean the gold spotted oak borer. We call it GSOB for short. And since its recent discovery in Simi Valley, Ventura County's iconic oak woodlands really face this unprecedented threat. So during this presentation, we'll talk about biology of GSOB, how to identify it, its devastating impacts, which directly increases local wildfire risk. And then I'll talk about some of Jolene's experience with leading multi-agency efforts like the Popinga Gawewish Poki project. I probably didn't say that very well, but a collaborative project partnership between the La Jolla Band of Luiseño Indians, the U.S. Forest Service, Calfire, the Greater San Diego Resource Conservation District, and Caltrans. Joelene will, or I will be sharing Jolene's practical landscape solutions. So you guys will learn tools like prescribed fire, strategic thinning, and community-wide planning to combat GSOB while also creating healthier, more fire-resilient forests for everybody. So to begin, when the computer works, we'll talk about GSOB, or the gold spot oak borer. We call it GSOB because you really cry every time you see the effects of this insect on the landscape. So you're sobbing. And so this invasive species is not native to our region. It's believed to have been introduced from southeast Arizona. That's where it's native. And it most likely arrived accidentally sometime in the early 1990s on infested firewood that was transported from Arizona to California and on the Cleveland National Forest. And it probably took multiple introductions for that to become established. And for years, this infestation went undetected. People didn't know what the mortality was. We've seen a lot of mortality in 2002. So that was almost 12 years later. We didn't know what it was. We thought it might have been drought. But finally, in 2008, it was confirmed that the gold spot oak borer was the primary pest causing this widespread, devastating oak mortality in San Diego County. So since then, it's been pretty much kind of over 25 years since this insect has been in California. And since then, it's, as you can see on the map, has spread into different locations. And these different locations, they're not a continuous spread of this insect. They're satellite infestations. So that means that it was isolated outbreaks that were not a part of the main outbreak in San Diego County. And I'll talk about that a little bit later and how this insect spreads and why we're not seeing that continuous spread of mortality from San Diego County all the way up to Ventura. So over the last 25 years, we've seen an estimated 200,000 oak trees have died, which is a huge number from San Diego to Ventura. And you can see that how these are kind of spotted throughout Southern California. And the movement is caused most likely from infested firewood being moved from infested areas into new locations, probably unknowingly, and that's how new infestations start. So all these satellite infestations are new infestations brought in from infested firewood from other infested areas. So you can see how it spread from San Diego into Riverside 2012, and then Orange County, and then LA, San Bernardino. And then last year it was found in Ventura County in 2024.
Hey, Kim, I have a question.
Yeah.
So at one of my previous jobs, it was at like a campground, and people could only really get their firewood through like an approved provider.
Yeah.
Is this part of why?
Yes. Yeah, that's one of the reasons why. Yeah. We want to limit the firewood because firewood could spread numerous insects and diseases. So really not moving firewood is beneficial in many reasons. But yeah, that would be one of the reasons we're pushing really hard to limit firewood with GSOB and for other pests. So what does the gold spot oak borer look like? It's right here on the screen. It is about as big as a grain of wild rice, so about 10 millimeters long, like a half an inch maybe. It's cylindrical, kind of bullet shaped. It has a flat head, and it has those six distinct yellow to orange spots. And really, entomologists are pretty literal when they name pests. So this is the gold spot oak borer. So it has gold spots, right? So gold spots in the back. It attacks oak, which I'll talk about in a minute, and it's a borer. So it's pretty literal. When you see a name, you can pretty much tell what kind of pest it is, what it attacks, and how it attacks it. So these are the adults, which you'll probably never see out in the wild. I'll go over that one a little bit. What you will see, most likely, are the GSOB larvae, which are seen here in these pictures. In the bottom left is a larvae eating some bark very slowly. These larvae, they're really small when they hatch. They're about 1 millimeter, so they're super tiny. And then they grow to about 3/4 of an inch. and they're really slender. And the way to tell them apart from other native wood borers is that the head is pretty much the same size, a little bit bigger than the body. What other wood borers, it's definitely much larger. And it has, hard to see on here, but it has two little pinchers at the base of its tail end here, and that is a key feature for GSOB and emerald ash borer. It has these two pinchers. If you see a larvae that looks like this, its head is just a little bigger than the body, and it has its two dark pinchers at the end, then that's most than likely GSOB, and it's on an oak tree. So that's what you're going to see, but these larvae are not found just on top of the bark. They're underneath the bark in that cambium layer, and I'll go over that a little bit, where that cambium layer exists on a tree. And it's not obvious. You're not going to see them wandering around. And as I mentioned, this GSOB likes, it prefers Southern California red oaks, and its primary target is coast live oak, which is really easy to identify by its long pointy acorns and spiky cupped leaves, as you can see here. And another highly susceptible species is a California black oak, which has smaller acorns but the distinct leaves that have resembled 8-fingered hands. So they look like the typical oak leaf you would see on the Northeast. And a less susceptible host is the canyon live oak, and this is you can tell this one apart from that it can have very variable leaf patterns, so it can look like a holly leaf, or it can be really smooth, but it has that yellow white coloring underneath, so that's kind of how you tell those apart. But California black oak and coast live oak are the ones that this insect truly likes, and we see affected and killed most often. So we're going to see, let's break down the tree. So start from the ground up. So here's the root zone. As many of you guys know, trees have roots, but they don't just extend right below the trunk. They extend really far out from the tree. They're usually about 1.5 times the height of a tree. So you can see here, it's about the height of the tree. They probably extend further. And this is where all the active water absorbing roots live. They live in that top 2 feet layer. That's where all nutrients and waters are absorbed for the tree and then taken up. If you look at the trunk, here's a cross section of the trunk. You can see different sections of it. So here is the outside bark, the bark that we see here. This yellow is phloem, and that takes the nutrients from the leaves and brings it down into the roots. That's right in the inner bark. That's full of sugars. It's the tree's food. And then you have here, the green layer is the cambium layer. And that's where this insect feeds. It feeds right in that very thin living layer between the phloem and the wood. And the wood here is called the xylem. And that is where it actively uptakes water from the roots. So it's kind of like pipes being taken up from the roots up into the canopy of the tree. And normally each tree, different species, have one active layer of xylem. Oaks can have 1 to 3, so it's a little different that way. And here's the xylem. You can see there's 1, 2, 3 layers here that's active. So this is where it feeds, and that's really important. The cambium is where you create new phloem and xylem, so it's really important to the tree, and that's really destructive when that cambium becomes impacted. So GSOB likes to feed in that cambium, as we just talked about. So first, it feeds right in this cambium layer, and that destroys that phloem. So that decreases the food transport. So the tree is no longer getting nutrients and food from the leaves into the roots, because remember that yellow layer is destroyed. So that's destroyed. And then as it feeds in there, it also feeds on the xylem, which breaks up those pipes, taking up the water from the roots into the tree, so the trees are no longer getting water up to the canopy. So it's a huge impact of this insect feeding on the cambium layer. So as this feeds, it's destroying more and more of those tissues that affect the tree over time. And eventually, over a period of 5 to 7 years, this tree will be overwhelmed and will die. So remember those satellite infestations we showed, and I said that it's not like a continuous mortality spread. This insect, when it was first discovered, we didn't know much about the biology, so we had to do some, had to figure out the biology of this insect, and we didn't know how far it flew, so they did studies to detect how far this insect would fly. And they're really, they're pretty lazy. They can fly for over a mile, but they usually just go to the next tree. But how they determined if this insect could fly is they glued it down to this little paper clip strapped to an instrument where it flies in a circle. And it's kind of like a treadmill. It just flew in a circle until it got exhausted. And then each time that insect flew around a circle, it was equivalent to a certain distance. And then you could tell how long it flew. So it flies just over a mile, but in 25 years, it's not gonna spread 200 miles or 150 miles it takes to get to Ventura County. So that's one reason why we see those satellite infestations as well. But what's really important is that knowing how this insect spreads and that we see these satellite infestations is really important to the foundation for creative and effective response, which we'll talk about when the integrated pest management strategies. So we can utilize the role of tracks, surveys, that kind of thing. And then we can look at the ecological impact this insect has on vital ecosystems. So what does the life cycle of this insect look like? So GSOB completes its life cycle in 1 year. So it takes 1 year to go from an adult laying eggs, developing into another adult. So during the summer, the egg stage in the summer, eggs are laid in bark crevices, and they hatch about 10 days. These are some eggs. They're really tiny. You're never going to see them. They're laid underneath the bark crevices to kind of keep them protected, because there's not these insects. These larvae are really small when they hatch. So here's larvae. They hatch in about 10 days, and then they'll bore through the bark, go through 4 larval stages, so they'll get bigger and bigger as they grow. You should see here, and that happens throughout the summer to spring, and then the larvae will form this hairpin formation, and this is where it will transform into a pupa and then overwinter. And then during the overwintering process, it takes a few months for this pupa to become an adult. And then, so you have these are just different stages of becoming adult. It's just becoming, has it identified as adult. You can kind of see the difference here. Here it's becoming more of an adult. It just doesn't have that protective coating. And here it's sitting in the pupal chamber. And that's right beneath the bark. You can see it's like a 1/4 inch from the bark. So it's right there. And the adult just waits there. And it waits until it gets a cue to know when it can emerge. And that cue are called growing degree days. And these are accumulated days that this insect needs to emerge. So usually, typically for this insect, we think it's about 400 to 1,000 growing degree days. And then it'll emerge once it has that growing degree day threshold met, and then it will emerge, leave these D-shaped exit holes, as you can see right here. So it'll emerge and it will chew just enough for it to come out, and it's flat on the back and bigger on this side because the insect has a flat back and a big belly. You can kind of see that right here. So it chews just enough to get out, and then it will emerge. It'll feed on the leaves for about 2 weeks to mature, and then it spends the next 8 to 12 weeks mating and laying eggs and starting a new cycle. So that's the GSOB life cycle, which is really important to know. And once your tree has GSOB, there's not ever a day that your tree is not infested with GSOB, with some stage of GSOB. It's always infested. So that's a little scary to know. So a little bit going more into the degree day models. This is how we can predict when GSOB will become active. And it's really important to understand that these insects are like reptiles, they're ectotherms, so they rely on external heat for the development. So the way we track that is called growing degree day models. So it's like a heat piggy bank. Every day, the temperature is above a certain baseline, in this case, 50 degrees Fahrenheit, the insect development bank gets a deposit. And they do this for pests as well. For the black locust, for blooming, the tree is known to naturally coincide with the emergence of emerald ash borer. So emerald ash borer has growing degree days to emerge when the black locust tree is blooming. So for GSOB models, we can use these growing degree days to know that after about 400 to 450 growing degree days, the adults will emerge, and the population will hit its peak at around 1,000 growing degree days. So it's really important to have this model because we can do predictions, and it will allow us to really precisely time our management efforts, like setting traps, doing treatments, when they'll be most effective. So in order to manage GSOB, you really have to use a lot of integrated tools. So it's called integrated pest management, where you do a lot of different things, management strategies to try to prevent this insect from moving and to manage it. So it's really all about timing. So our strategies are built around the beetle's life cycle because the temperatures vary each year. But really the most critical period is from June to July. And that's when the adults, peak beetles emerge. So those degree days are met. Most adults are emerging then, and that's when they lay their eggs. So this means that's a really good time to do management. You can do chemical sprays, you can do other different things, trapping, different things to do management strategies and to tailor your management strategies to what your goal is. What's really important is we know this peak window for adults is June and July. So if you want to do a contact insecticide, you want to spray that before they emerge. If you want to do a systemic, you want to do it in the winter time when the trees are uptaking water and can get that chemical distributed throughout the tree. And I'll talk about that in a little bit. And it's what's really important is that larvae, as I mentioned, are in the wood year round. There's not a single day that an infested oak tree is not and has one part of the GSOB life cycle. So when oak wood is cut, it's a threat. So if you cut firewood, that actually accelerates the development and causes the beetles to emerge off schedule. So if you cut it in March or February, you're going to have beetles emerge when they're usually not supposed to. So that also is a good management tool, knowing that information. And it also allows us to know we can do mechanical grinding, can be done year round, and I'll get into that. Tarping, all these things are based on the biology of GSOB. So what do you do for managing GSOB? Well, first you have to know where it is. So you want to detect it early. But trapping methods really historically have been labor intensive and really some of them are based on pure chance. One classic method in the top left here is called branch beating. Is when you take a sheet, have it spread out, and you put the branch over top of that sheet and just smack it really hard until all the stuff falls into the sheet, and you can see the insects because they pretend they're dead. So it's when they fall into the sheet, so you can collect them easily and count, and then use those counts to see how population levels are. Other methods are like our flight intercept traps, like this one in the middle, the lingering funnel trap, or the sticky prism traps. These for GSOB, they're pretty much based on pure luck. If you get something, if you get one flying into them, these insects don't see very well. They just see shadows or patterns. So they see this object that looks like a tree, so they might fly into it. But like other insects, GSOB does not have a lure. It's not attracted to anything. So if it flies into these, you're just really lucky that you got in the right spot at the right time. For you, unlucky for the insect. But Joelene earlier this year, she had a kind of a breakthrough. She tried a sticky band trap that she used with spongy moth. I see in the top right here, and that's just saran wrap wrapped around like a few inches, maybe 4 or 5 inches around the tree. And you put some sticky material on the outside of it. And then when the insects GSOB emerge, they usually crawl up the tree. So you're able to, and they encounter this and they're stuck. So you're able to trap those adults and kind of get an idea of what the population level is in that tree, at least, and sometimes in the area. In 3 months, she caught 45 of the GSOB on that tree. So it could be a good detection for amplifier trees, or if you have it in the area, just cover a tree. And if you get GSOB, sometimes it might fly into it, it might be crawling out. It's a really important tool for identifying GSOB. So what is the impact of this insect on the ecosystem and on aquatic sites? We get a lot of questions about that. Oak mortality is huge. It has a lot of ecological impacts. And GSOB oak mortality is really severe, especially in critical habitats like riparian corridors. These insects like large, healthy coast live oak and California black oak. And the more water they get, it does not improve survival. So when you get high density oaks, mortality in these area, you get fuel loading is exacerbated. And that creates a dangerous paradox, because you have this high density of oaks along our creeks and rivers that leads to massive mortality, and that creates extreme fuel loads and hard to access areas, really. So you need a rapid response for these situations. So when you have a detection of GSOB in these situations, the land managers are really in a race against time to find funding for the very limited treatment options. And this really isn't a hypothetical problem. We've seen this a lot right now in the Dawson Los Menos UC Reserve. This has been served as a fuel hazard abatement notice, from the county directly because of the fire risk posed by their dead and dying oaks from GSOB. So the threat is immediate and the consequences are real. So it's really hard to manage this insect in riparian areas. And I'll go into that a little bit, but it does create a fuel hazard. Those fuels are standing and then they fall down, that fuel loading changes and causes a lot of issues. And we can visualize this slow motion devastation that GSOBs cause over time by long-term treehouse surveys. And Ruth Wallen has created this visual indicator of the progression of this infestation's relentless progression. So it's called Walking with Oaks in Pine Creek. It was in 2014. And here you can see the shadows of where the trees were and how they've fallen, and how this really has created a huge impact on the ecosystem, altered their fuel loading. Definitely it has a lot of ecosystem impacts here. So we've seen how GSOB can impact an area, how the devastation can cause, and then kind of in the life cycle, but how do you know you have GSOB? What do you look for? So the first thing you want to look for are the signs of GSOB. And signs are the indicator that the pest was there. It's made by the pest. So it's if you see that, you know that that is from this insect or disease or whatever you're looking at. It's made by that that insect. So the most definitive sign is this distinct D-shaped exit hole. Keep pointing at the wrong thing. D-shaped exit hole is seen right here. So if you see that on a large diameter, healthy oak tree, that is 100% GSOB. It has to be the right size, but this insect is the only known insect to attack, only known wood borer to attack healthy coast live oak and California black oak in California. If you see that, this is a sign you know the insect has been there, is left, and you have damage under that tree. Other signs that you'll see are the beetle chewing out, the pupal chamber, the insect itself, a pupal chamber is right here, the larvae. But seeing all these kind of ones down here in the bottom, the larvae and the galleries, you have to do destructive samplings. You need to chop back that bark in order to see that larvae. It's right in that cambium interface. And you know that bark on coast live oak and California black oak is a couple inches thick on these larger diameter trees. But if you see these frass-filled galleries and the larvae, 100% know it's GSOB. If you see this pupal chamber with the insect in there, you know 100% it's GSOB. Once you look at the larvae and it has those pinchers on the end, 100% GSOB. So when you see these, those are signs you know you had GSOB. Another way to kind of hone in on a tree that might have GSOB are looking at the symptoms. So symptoms are the reaction of the tree to some sort of injury. So if you see some bleeding or staining on an oak tree, it could be GSOB. It could be 12 other things too, but it's an indicator that something's going on with that tree and you should check it out further. Usually, so something is disrupting that area, causing the water, the xylem vessels to be broken and the water accumulate and that trunk to bleed. All that fluid is leaking out from the bark. If you see cracked bark, this is an indicator that the tree is dead. So something's going on. Usually trees don't have dead cracked bark. So obviously something's going on there. If you see woodpecker foraging, remember that these pupa are right underneath that bark when they're ready to emerge, or in that little pupa chamber, just hanging out till they get those degree days. They're right there, and they're really high protein, tender morsels for woodpeckers. So they'll flake off that bark and pick out these GSOB larvae. So if you see these flakes and some pupa chambers, that could be GSOB. Now, not all woodpecker foraging is GSOB. These are sapsucker woodpeckers, which, make those holes in a line. They're not looking for insects. They're getting the sap from the tree. There's acorn woodpeckers that are causing, that store acorns. Those are not associated with GSOB or any other type of insect. But we see this woodpecker foraging on a lot of trees that have bark beetles as well. They're just trying to get those insects that are high in protein as a good food source. So if you see bleeding, cracked bark, woodpecker feeding is a good symptom. Something's going on with that tree. It may be GSOB, it may not, but it's good to check it out. And you can look at thinning crowns, which you see thinning crown would mean like there's death of the branches. You'll have the crown will look really thin, so you won't have a lot of leaves on there, and it doesn't look like a good tree. If you go up to a nice healthy tree, that's a good tree. You're like, I like that tree. This does not look like a good tree. So the tree doesn't look like a good tree. Check it out. There's something causing that tree to have a smaller crown, losing its crown, having dead major branches. And as this infestation progresses, you'll get more escalated sudden death of the major branches. So as the GSOB becomes more infested, you'll get more and more advance of death of the crown. Also, if you see brown leaves on trees in the summer or when they're not supposed to be dropping the leaves, because the act of trees losing their leaves is an active process. It involves chemicals, and it's not done just willy-nilly. It's an active process. So when leaves are hung onto the tree, that means something happened. These trees, this insect died, or this tree died for some reason. Those trees were not they're not shed off like they do in the fall. They're actively maintained. So something's going on with that tree, something to hone in on. And this is really how we see a lot of the GSOB trees infestations. We see these brown leaves holding on to the trees, and we go and check it out further and see the exit hole. And then we chop in or see woodpecker feeding. And we just chop in and see those larvae, and then we know we have GSOB, but it requires further investigation. And also, mortality centers, usually where the infestation will radiate over time. Remember I said these insects are really lazy. Either they'll stay on the same tree or they'll go to the next tree to feed. So you'll see these mortality centers kind of emerging and getting better. Doesn't mean it's GSOB, root rot does the same exact thing. So you could have something else going on, but it's an indicator that something's going on with that forest or those trees. So these are things you want to look for. Not a good tree, bark bleeding, woodpecker feeding, that sort of thing. So this D-shaped exit hole, seen right here, really tells a critical story. So that means the adult ghost spotted oak borer has successfully completed its life cycle and has emerged from that tree. So the beetles, they really focus on that low on the trunk, typically the first 2 meters, 6 feet or so. And as the chart shows, the vast majority of the exit holes are concentrated in that lower 6 meters of the tree. So that makes ground level inspection really effective. They're really nice. They attack the lower bowl, easy to tell. They're not high on the branch like emerald ash borer, and make it easy for us to find them, which is one nice thing they do. But because this activity is so concentrated, the entire lower 10 meters of any oak should be treated with caution. And most importantly, finding these holes, even on a tree that looks fairly healthy, with a little bit of crown dieback, less than half, is a clear infestation, a clear sign that this infestation is really active and the beetle is thriving. So one way we try to see where GSOB is we do surveys. So to know the infestation level, and that will affect our management strategies. So we needed to standardize our surveys. So we used a simple exit hole rating system to really assess the severity of an infestation. So as you can see here, it's from 1 to 3, with 0 being no holes, obviously. And so you go to a tree, you look around the bowl of the tree as far as you can see, and count how many exit holes you have. And that'll determine on the infestation level of that tree. If you get 20 exit holes, you have a exit hole rating of 2. This is really critical for a treatment threshold. From Jolene's experience and many others, once a tree reaches a rating of 2, meaning it has 10 or more exit holes, really treating this tree, applying insecticide is not likely to be effective. That internal damage, that cambium is too far advanced to save the tree. So it's really important to count the holes to see what the infestation level is, and that'll affect your management strategies. We also gauge tree health on staining. Remember we talked about staining earlier and the damage. So as I mentioned, staining is just a symptom. It's not necessarily caused by GSOB, but it is something to investigate further. So again, just like the exit holes, we have a scale. You count the number of stains that you see on the lower trunk, or on the trunk you can see. You count them, and then that will affect management strategies. So If we see more than 10 staining spots, it's a 3. And with the more severe rating, the bark becomes cracked, and this obviously affects management strategy. So again, if you see a rating of 2 or higher, you see a bunch of stains that are 6 or more, really, it's generally too late for insecticide to be effective. That internal damage, again, is already too extensive. So you can kind of see how management strategies are caused by the infestation level of the trees. If it's a 1, you can probably treat that tree. And we also look at the crowns. Remember I said if it's a good tree, that good tree is number 1. And again, and a 5 is a dead tree. And then there's variations in between here of how severe the infestation level is. For the practical lesson here is really critical. If you have a tree that's already showing significant crown damage, insecticide treatments are unlikely to save it. That damage is way too advanced. The tree is not uptaking water, nutrients. It's just trying to hang on. If anything above a 3 or more. But it's also really important that the crown can be a false negative too. There's a lag time on crown response and compared to the damage of a tree. So a tree can look perfectly healthy while a lethal infestation is really developing under that bark. So you might have a tree that looks like a 1 or a 2, and you have a lot of infestation levels. It takes time for that crown to react. I've seen, not related to GSOB, but I've seen trees with the bark blown off from lightning completely around the tree, and 3 or 4 months later, the tree still has a healthy crown, is dead and doesn't know it. So there's that lag time of that cambium layer being affected, the infestation level, and that crown showing symptoms. So again, we can show, you need to look at the exit hole and the crown and the staining to know how to assess the management strategies and whether to treat that tree or not. In new areas, it's really helpful to have drone imagery for planning for a project. You can pick out the dead trees in areas that you may not be able to hike to or see, and it may tailor your surveys areas too. If you don't see any dead trees, then that may not be a priority area for surveying. So it's actually really beneficial for surveying. So the stressed trees are shown in the brown, as brown and green and light purple. You can kind of see there's a bunch of stressed trees in here. So this would be a good priority area to survey. So what do you do when you find it? And the big question of any infested site is always, do we need to treat the tree, or is it time to cut down this tree? And really, these decisions are guided by a few key priorities. So first, we need to protect the next generation by saving new seedlings, right? You want these forests to continue having oaks and keeping that resource. So we also have to act quickly to remove the obvious hazards. That means trees are dead and dying or structurally unsound. You might need to remove those, especially those in high traffic areas for managing fuel loading. But with limited time and money, it's really hard to make these tough calls. We need a consistent way to make these tough calls. So we use those exit hole strategies and a threshold to kind of gauge us into making those management strategies. So a lot of people use the exit hole count over 25 exit holes to determine that infestation level has progressed too far for treatment to be effective. And usually, so that's where you remove trees in those high hazard areas. But also what you want to do is remove amplifier trees. And these are really site dependent, but this is where you have a lot of the insect population in one tree. You can have trees that are over 100 holes. And if you remove this tree, you reduce the insect population in that area. So that also has become a management strategy for depending on the funding resource that you have. It's not a perfect biological rule, but it's a really useful guide to help us use resources. And it's really a difficult decision to cut a tree. But once you cut the tree, you peel back the bark and you find those distinct frass lines or galleries. You can kind of see those right here. That whole cambium has been disrupted. So that tree definitely was failing. and was on its way out. So removing that tree, reducing the insect population, could be definitely justified by removing that tree. All right, so we talked about amplifier trees. So
Hey, Kim, just
yeah.
give you a heads up. The advertised time was for ending at 7, just so you know.
Oh my God. All right. Sorry, I'll go quick. Sorry, Jolene.
No
So for
worries.
No,
these,
you're onto great stuff. I feel like I'm learning a ton. So
all right, but I feel bad. I could talk for 8 hours on this. I'll go faster. I'm sorry.
No, I think it's great. And if something doesn't get covered, maybe we can always schedule a round 2 or something.
yeah.
Okay, I will try to move it along. Okay, so we'll talk
See, now I
about,
feel bad for even telling you.
it's all good. It's all good. I kind of thought I was dragging on. So we'll talk about best management practices for GSOB. This is really important. Really, we want to limit the movement of firewood, right? Because that's how this insect is moved into those satellite infestations. So we want to stop moving firewood, because even a single piece of infested firewood can house 28 adult insects can emerge in a month. So it's really easy to start a new infestation by removing firewood, infested firewood. So we really don't want to move infested firewood. If anything, you take anything from this talk, don't move firewood.
I heard from my coworker that like they can live in firewood for like 2 years or something like that. Is that true?
Yep, I'll get into it. Yeah, they can live.
Oh, it's right there. Yep.
Yeah, for 2 years, exactly. So any wood that has been affected with GSOB 4 inches or greater in diameter can harbor insects for 2 years. So this is a huge issue for management, because oak firewood is a really critical resource. If it's there, people like to use it for barbecuing, home heating, camping. It's a really good fuel source. So really a good rule of key is to assume firewood is infested, regardless whether it looks old or dry, fresh or moist, that sort of thing. Because even if you don't see exit holes, it could still be infested. It could be a new infestation, then they cut down the tree and then it can emerge. So yeah, don't move firewood, because it's live in there for up to 2 years. So another option besides not moving firewood is chipping and grinding these the wood, the infested trees. You want to chip this wood down to a size of 3 inches or less, and that'll kill most of the insect and reduce the amount. It'll reduce the wood to a size where the insect can't go any further in its development if it does survive. So chipping it is a really good option, and we always say to keep it on site just to be really proactive, really safe. But you also want to make sure when you chip that your spreading depth your site can allow for it, because usually you don't want to have chips more than 3 inches according to local fire ordinances. So you really want to make sure the site can support the chips. If you want to keep the wood and use it for firewood, that's fine, or for later, but you want to cover all that wood so these insects don't escape. So we used to recommend heavy duty plastic sheeting or tarps. They work, but you have to cover these things for 2 years. So, and these tarps notoriously do break down in the sunlight, even though they're UV resistant. If a squirrel runs over it, they get torn open. So you can use the tarping if you want to check it 4 or 5 times a month for 2 years. It does work, and it just keeps those insects contained. You want to make sure that the wood is completely covered. You don't want like it just laid over the wood. It's got to be completely covered, because the insects are still emerging. You're just keeping them contained so they don't spread further. And you want to make sure you have that air gap. So you don't want something right up against the wood, whether it's a tarp or aluminum screening works really, really well, because those insects will just keep chewing through. They'll think it's the bark still. So they'll keep chewing through. But if you have that kind of air gap, then they'll just kind of hang out and do their thing and they'll not keep chewing through. So that's really important. But you can do this. You can use shelters, you can do tubs, anything to keep them contained for 2 years. That way the wood is dried out, all the insects have died, and that wood is okay to use. Debarking is another option. People like to keep their oak wood, and really those larvae, GSOB is really only in that bark, right? It's not in the wood. It's right in that bark and that cambium. It does not enter the wood. So if you remove the bark, then you're good, but you also have to treat that bark. You can chip it, you can bury it at least 12 inches deep, you can burn it, you can screen it. That you have to, if you screen it, it's got to be screened for 2 years. So you can use that wood once the bark's removed. You just have to make sure you treat the bark, because as you've mentioned before, a 1 foot section of bark can release 28 GSOB. You can season the wood also if you have an area that's really infested. Some areas in San Diego, this works really well. You can leave the wood on site and have it seasoned for 2 years in the open. Obviously, those adults are emerging and spreading all over, but if in an isolated area where you have GSOB kind of present all over, it's an option. But you do want to tag those trees and show that when it was infested, when it was seasoned, and when it can be used. That way you kind of keep an eye on it, so you're not moving infested wood unknowingly. Thinning is a great forestry management. It opens up the stands, it increases the water and nutrients to the residual trees, and improves tree health. But it really effect on GSOB is unproven, because these insects like those large, healthy diameter trees. It may not work for GSOB, but for natural forested areas, it really is important in improving those site conditions and the health of those remaining trees. So you don't want dense forest, because the site can only support so much basal area, so many trees. So the less trees you have, to a certain extent, the more healthy they will be. And pruning is also a good option. It's not a cure for GSOB. It won't affect the infestation at all. But it does affect the younger trees, because when those trees are dying from GSOB, you're going to have that increased solar radiation on those seedlings all of a sudden when they die or they're removed. So pruning helps kind of strengthen those seedlings to become prepared for getting that increased sunlight when they are newly exposed to the dead mother tree. Heat treatment is really important. I want to make sure we go over this. It's a really promising solution that Joelene has done a lot of work on. Her recent research has shown that a standard heat treatment was 100% effective at killing GSOB and infested wood over a 4-year study period. So she found that the protocol is to heat the middle of the wood, the core of the wood, to 60 degrees Celsius or 140 degrees Fahrenheit, and maintain that core temperature for an hour. And this is the same treatment that they use for emerald ash borer. This research, just full disclosure, is currently pending peer review, but it has really good results, and it's going to be published hopefully. But this is a really good method because it has not been shown for GSOB before, and is really important that we can heat treat the wood, and then that wood can be used for firewood and for whatever, and can be moved safely. Another option is pile burning for GSOB control. You can burn the wood, and obviously that's going to kill everything in it, right? And that's nothing going to survive. So burning GSOB infested wood, totally fine, but make sure you get permits that are required, especially for homeowners. And there's new research that she's also found on heavy charring. So it found that recent studies found that heavy charring the entire surface of wood for at least 7 minutes can reduce GSOB emergence by 96%. That's huge. So this is also a good treatment method that she has found, and also again is currently pending peer review. But this is huge research and can be used for a lot of different management strategies. So there's also, besides the labor-intensive management strategies like chipping and burning and physically sanitizing the methods, you can also do chemical treatments. But the really important to understand these treatments are really preventative. They're not a landscape scale tool. They're to protect healthy, high-value trees from becoming infested in the first place, not to cure trees that are already in decline. So these chemical applications can meet forestry goals like preserving heritage trees, protecting trees in high public use areas. So that's really important to know. So there's a couple options. You can do contact sprays. I'm trying to go really fast. And these are protect healthy trees. So it's a barrier. So it's a preventative spray only. So it won't kill the larvae inside the tree. And it does not move inside the tree. It's just on the outside of the bark. You spray it on the lower bark and the larger branches. And then the insects, when they come in contact with that, either emerging, they're eating the way out, they will die, or when they're crawling on it, laying their eggs, they will die. So it prevents those trees from being further infested. But if they're already infested, it's not going to affect the damage that's done to the tree. Another option is systemic insecticides. These are more of a direct approach. And it's really targeted, so it has minimal environmental exposure. The main chemicals are injected into the tree. It's taken up by the tree. You want to do this, as I mentioned in the beginning, during the rainy season where that tree is actively uptaking, so you get the most distribution throughout that tree, but just know it's not going to be distributed evenly throughout the tree. You're not going to have this nice, good distribution throughout the entire tree and up into the canopy. It's going to be scattered depending on the tree's vascular system. And if it's too damaged, if you have a lot of infestation, it's not going to uptake this. So it's only for low infested or non-infested trees. This is good for 2 years. The contact is for 1 year. You have to spray contact insecticide every year. This you have to do 2 years, but it's really not a long-term good solution because you have these holes on the base of the trees where you do these injections, and this opens up areas for other pathogens to get in and cause cankers, as seen here. And then you have these holes on these trees. You have to do this every 2 years. So it's not a good long-term solution, but it is an option. There's bark applications. So there was an application, studies done on a bark application with a surfactant. That just helps to treat the insecticide go into the tree of dinoterfurin, but it needs more research for this. It is being used and people say it works, but we need scientific research to show that it actually works. The chemical enters the xylem and it's carried up through the tree just like a systemic, but it's sprayed on. Soil drenches are not for GSOB. That's where you inject the soil with this chemical and it's uptaken by the roots, but really it's the wrong target because the drenches usually apply at the trunk and the fruited roots, as I mentioned in the beginning, are way beyond the canopy. So they're not even reaching the roots that need to be taken up this chemical. And depending on the soil conditions and the moisture, which are really rare in Southern California, these chemicals are just going to drain and leach away in the soil and cause more damage. So it's not really an effective way of management for GSOB. And obviously, to wrap up, we have a lot of tools to fight GSOB. And with the chemical options, you obviously have to have responsibility and know protection of our waterways. Don't spray near water before rain or in high wind. Just read the label. But really the strongest defense that we have is long-term strategies, is keeping it out. Don't move firewood. Remember, the only key thing I want you to take away today is don't move firewood, and improving forest health. And if you want to keep track of where pesticides are being used and when they're being used, you go to this website and it'll give you that information. This is where Joelene is supposed to take over, but I know it's 7 o'clock.
What would you like to do? Do you want us to keep going until we finish, or do you want to reschedule?
If you want to power through how much longer do you think the last bit would take?
Maybe 10 minutes or so.
Yeah, and if people need to go or start eating their dinner or whatever, that's fine, but I'm gonna record it. So anyone who has to go can keep an eye on our YouTube channel. We'll announce it over Instagram and in our newsletter when the recording comes out. But yeah, if you guys have 10 more minutes, you guys can keep going.
Awesome. Thank you. And thank you, Kim.
I'll stop
can you guys,
sharing, Jolene.
oh, why don't,
Or you want me to keep sharing?
yeah, sorry, I'm thinking, stop sharing, I'll share, and then we're good.
Okay.
See. Can you see my screen?
It's in the process. There, now I see it.
Okay. Oh, I have to push play. And fly through the reservation. I'm sorry, presentation.
While you go through it, Kim, I had a question. Are other California oaks, are they just more resilient, or does this insect just not like them as much? What's the reasoning there?
Yeah, we usually see them on the California, like on the red oak species. We think Julian probably has more to add, but more that the thick phloem. We think maybe it has that nutrients and it just seems to like the thick phloem of the trees. We've tested there, or I haven't, but the collective we have tested like cork oak and valley oak and interior live oak, and to see which ones have been susceptible. And really, they might have some, they can host some of the GSOB, but it's not nearly as much as like the red oak species can.
Interesting.
And just to add to that, as researchers, we're never really sure. So it's kind of comparative, like in canyon live oak forest, it can be hit very hard by gold spotted oak borer. But if the canyon oak is mixed with the black oak, the GSOP are going to go for the black oak first. Each host species is a little bit different. And the concept of a host species to me as a budding entomologist was really hard to conceive, but because most people think of like flies live everywhere, they don't need anything in particular, they just need carbohydrates. But gold spotted oak borer needs a specific set of conditions that it has evolved to reproduce in, and it has to reproduce within a host oak tree. So as a species spreads, it will accumulate more hosts, but it has to find that host that supports its lifestyle. So it's a little bit complex. It can reproduce a lot higher numbers in thicker bark, but just in the same and thin bark, sometimes they'll pupate in the outer sapwood. So there's always that variation with research. We can tell you how it is most of the time, but there's always going to be that exception. The each side of the bell curve always a little bit different. But it's a challenging thing to really try to nail down, but hopefully we'll have a better explanation for you one day. Okay, so going into, and thank you so much again, Kim, going into the GSOB Highway 76. I've been telling everybody about this for years. Finally, our local RCD was able to really pick up the tab on this one and started getting everybody coordinated. So I had this map down here on the left, which I'm actually going to go through, but I'm also really excited about this project because it's finally moving. My screen's not advancing. There it goes. Okay, here we go. So in this map done in 2020, obviously trees were dying in a real high density along the highway. So the RCD got all the partners together, the U.S. Forest Service, Ray River Ranch, it's like a club, where people live, SDG&E, Caltrans, Calfire, the private landowners, San Diego County. Over like 50 people were at our first meeting. The goals to protect human life, reduce water damage, wildfire damage, increase ecosystem resilience, increase interagency collaboration, and to protect our infrastructure. SDG&E also has high voltage lines going through there. And something else I'm also pushing is that the Department of Defense, they have communication towers nearby. So it's really important that we keep wildfire away from this area. We want to implement a landscape level management practice and do all those things that benefit forest health, thinning, sanitation, salvage, restoration. We want to help reinstall those vegetation mosaics and natural fuel breaks. Fire is an inevitability. It will come. It's just a matter of when and where. So to change the landscape so it supports fire on regular intervals is our key goal. So we're going to be leveraging research and supporting the community to do this. Here is a highlighted map of this key corridor area east of the reservation and west of Lake Henshaw. Here, the Calfire Fox Camp sits right in the middle. I always take people on tours. We park across the street from Calfire. They look at us funny, but then we point to all the dead trees. I took a bus of reporters there once. It's pretty funny, but it's really essential. So they're also a really big partner in this project. And then here is our next proposed project to address our piece of the pie here, if you will. We're planning to reduce the fuels along the highway. This picture shows our North Trading Post burn unit. It looks over the highway to the north, and this is where we're going to implement cultural burning adjacent to the highway with Caltrans's support, and hopefully turn a new leaf in fuels management. Here's a consultation letter from the Forest Service telling us or asking for comment on their choice to treat 1,405 individual coast live oak trees along this corridor, along 75 acres. 78 acres, I'm sorry. Here's their map of their project, and the tree removal is going to be the area in the pink. We got that last month. I was really excited. The wheels are turning. Our critical partner is Caltrans. They're currently drafting contracts to have 178 or 190 something trees removed along this corridor. They've also stepped in to increase the fuel reduction along the whole highway from the 76 to the 79. I'm sorry, from the 15 to the 79. So they've really stepped up. I think just a couple months ago, another oak tree fell on the road. Someone ran into it, minor injuries, but I think that's the third collision with an oak tree along within this 5 miles that we've had. This is unfortunate, but it's really brought us to take care of the problem. So I look at it as a good thing. It's terrible that all these trees are dying, but we really can't ignore managing the forest. So there's a better way forward. So the Payom Coachum, the La Jolla people, they have a strong history of fire. Here's our fire chief, Chief Wes Ruiz. He's been 40 years in the Forest Service. He retired, now works for the tribe and is the chairman. He has a lot of expert knowledge and connections, and that's really key to help get this project done. Here is a picture from one of the Forest Service aerial satellite drones, something from the sky. I actually cleaned that house 15 years ago before I started working in natural resources. So this is, it's pretty Captain Obvious kind of stuff that needs to be doing. So just to let everybody know that you don't have to be an expert to start working and making meaningful results. But you can see all the dead pictures on Palomar Mountain, and that looks like about 30 to 50% tree mortality. That was taken 5 years ago. I don't know what it looks like now.
I'm gonna go camping at Palomar next month, so I'll let you know what I see.
Awesome. Yeah, it's so beautiful up there. Don't camp under any oaks. Especially black oaks. They drop limbs on a good day. GSOB has a lot of fungi that they kind of support, not intentionally, but when they chew and they kill tissue, the fungi move in and it starts a rapid decay of the trees. So they're fall hazards. They even know arborists on the East Coast that they won't climb any trees that have been attacked by ash borer. Many people have been killed. So that's also a consideration that we have, when managing campgrounds. It's a really severe problem. We don't want people to get hurt. Here's a picture of Area 8 in the La Jolla campground. We've had 50% canopy loss. We went through and we cut all the dead and the dying trees out. It's actually looking pretty good now. It's been unfortunate. So we do a little bit of everything. Forestry is not a standalone practice. It's an art form. So you have to do the hazard tree removal, thinning, you have to survey, you got to make sure that what you're doing is working, you have to replant because nothing's 100% effective. Just start it now. And once we cut all this material, we got to get rid of it. So we got to utilize that biomass. We got to train our workforces up. We host trainings every year open to the community, and it was really cool. Like even somebody from Temecula, no relation at all front to the tribe, came down, did our fire training. He now works for us, and it's amazing to see, us sharing with the community and the community sharing back. And the goal is just to improve forest health. So part of your programmatic plans should be installing those shaded fuel breaks. You need them anyway. So this is just GSOB is just your push to get it done. And I will add that once GSOB infests an area, the cost goes way up. So if you can start it now before it gets really bad, it's your funding will go further. Thinning, salvage, and sanitation, and then limbing, also limbing up, bringing up that canopy so your fire travels along the ground is really important. Here's some pictures from our campground. We've taken out about 1,000 trees and about 200 acres over the past 5 years. The tree mortality has slowed. I think there's only like about 5 immediate trees that need to be cut next year. So that thinning has been impactful. Also, after that first wave of an infestation moves through an area, things will slow down, but it's all about how much food is there. Here's a picture of the hillside. After we did some cutting, we had to do some more cutting. We actually burned most of this. As you can see here, our view from the top of this hillside. Here's our morning briefing. We invited all the fire crews. It was truly interagency. We had La Jolla, Palma, Paula, Rincon, Verona, Calfire, the BIA came down, state parks came down. They all had a wonderful time. We did our test burn just like you should, make sure that all the conditions are perfect before you complete the project ignitions. Here's a view of the smoke. Prescribed fire, as people are still getting comfortable with it. But as you can see in these pictures, this fire was started in the higher part of the hill. They backed it down the slope against the wind. And notice you can barely see the high voltage power lines running through. I was so nervous. Chief told me not to worry. The electric guys told me not to worry. They had it covered. Again, those relationships built over the last decades. Those people, they built the knowledge that everybody uses today. So it's really important to have those connections. Here's from the bottom of the hill. As you can see on the left side of the fire line, it's unburned as planned. State Parks held that line and the fire progressed to the west. They had to cut the fire off early because a couple of fires broke out in other parts of the county and they didn't want to tie up resources. So they cut the fire off at 2 acres, but here's a picture of it. Here's 1 year post burn. It's got really good regrowth. I was pretty sure those trees were going to die before we started the fire. They're completely damaged from the GSOB, but they're actually looking really good. So we'll see. I could be proven wrong. Those trees might survive. It'll be interesting.
Do you think the heat from the fire like helped the infestation or something?
It might decrease the infestation. It might decrease the fungal or bacterial loads, which are really rapidly causing GSOB to have these rich, delicious meals within the tree. Ash and char have historically been used to as insecticides for thousands of years all around the world. So traditionally, the indigenous people used fire. The smoke would push the insects out and just make it not ideal conditions for insect reproduction. So it could be a little bit of everything. Again, I'm going to start saying maybe before every answer. But the hardest problem with GSOB because is that it has an annual life cycle and we can't put it in the lab, and it's really hard to keep alive as a larva in the lab because your wood is constantly drying and it needs to complete its life cycle in certain stages. So it's challenging to work with, but we're not giving up, and we'll keep going. So Kim's researching wildfire activity on gold spotted oak borer populations and researching the cultural and prescribed fire burning aspect. Hopefully we'll have something for you in 10 to 20 years, but it's forestry. It takes 20 to 100 years to really cement things down. So again, your goal is forest health, and anything else we learn is incidental, but good. And thinning and prescribed fire have always been used to increase forest health. Let's see, and I just talked about, the intentional fire is based on the fact that ash and smoke kill insects. GSOB has quite a few known natural enemies. There's probably more. These are the big ones that we know about. We found Vulca indica for the first time on the La Jolla Indian Reservation. I was really hoping it was a new species, but it was 100% identical to the Maryland species. The paper will be coming out later this month. We have some Braconidae wasps, Calisota elongata. I just identified this another, or I didn't identify it. It's a eupalmid wasp. I collected it out of an infested GSOB pupal chamber tree with a pupal chamber. And then we have this chalcid wasp. But I also found in low numbers Vanessa Lopez, who researched parasitoids, found at 1 trichogrammatid egg parasitoid, but we haven't found anything that has really been effective on reducing the population more than 3 to 5%. So, and I also speculate that the more woodpeckers damage on a tree, the more that they're eating those GSOB, the more they're opening that tree up to outside infection. So that can be like a negative feedback loop. And then you can see here, there's also mites. These mites start building in the summertime. and they start knocking down my research specimens. I'm not sure how their activity is out in the field. It's hard to see mites in the wild, but this beetle got so inundated with the mites he couldn't fully emerge. So there's a lot of things to research. Hopefully we'll learn more. Key messages: GSOB is a deadly invasive pest causing widespread oak mortality, and each early detection is essential. And then the triage rule: proactive treatments can protect healthy or lightly infested trees, but are ineffective on trees already showing moderate to severe damage. The best and most sustainable defense is exclusion. Don't move firewood. And then our path forward is integrated pest management, and it's essential to make knowledgeable, responsible decisions and protect our environment. And please keep supporting our research and outreach, because we need to get better. We need to figure out how to communicate better and educate better and more effectively, and we need to manage better. So thank you for all your time and support and questions. Kim's email is up here. My email is up here. My advisor, Mark's email is up here. And we can take any questions if you have some.
Thank you. I have a comment just that me and my coworker who are here, Mary, we both do outreach work. And I'm like, okay, we got to get started on some outreach for Ventura County. This was a good primer for us to get prepared. If anyone has a question, you can type it into the chat, or you can just unmute yourself and just ask it out loud. And I don't know how you could do a short answer of this, but just from a RCD perspective, I'm kind of wondering what kind of initial projects should an organization like our organization, the RCD, what should we be looking for? What kind of work should we should be really prioritizing with it being spotted in Ventura County?
Probably early detection, rapid response, and the community wildfire mitigation planning, because everything you do for forest health and wildfire mitigation will help GSOB.
Yeah, great. And if we want to stay, is there a way for us to follow your work or stay up to date on what's going on? Because it sounds like you're really doing a lot of research and finding out new things.
Yeah, that's a great idea, Kim. We need what do they call an advertiser person?
Yeah. I know, I need a Instagram post or Instagram site or something. Yeah.
Yeah, a PR coordinator.
Yeah.
I know our IT department is making us a department website where I'm going to be putting a news feed on there. So every time we do something that's on the web or something that's on the news, it'll be on there. We just released some YouTube videos on La Jolla Band of Luiseño Indian YouTube channel. It's got some exclusive footage of the GSOB mating and reproduction cycle. And then it also talks about that fuel reduction work, and there'll be more videos released as well. One covering the GSOB highway coordination.
Cool. And I have one final question. I'm the person with all the questions. When I go down to San Diego, from the Riverside area where you are, if I'm taking, I think it's the 5, and sometimes on the hills, I see a lot of dead trees, look like oak trees. Is that GSOB? I know, hard for you to tell, but
Which area?
if you're going from Riverside down to San Diego, closer to San Diego, but I was driving down there and I saw hills and it was just a bunch of dead trees. They kind of look like oak trees, but just as you were talking about it, I was just kind of curious if it was likely to be GSOB.
If it's from Riverside, you're probably on the 15 to 15.
Yeah, 15. There you go.
Okay. Yeah. I'm not sure what the view looks like from the highway, but when, yeah, I drive out through Highway 76 or Valley Center Road or the Highway 78 or 79, it's all GSOB or the 371. So
A lot
can
of highway.
better.
Yeah.
Yeah.
All right, I don't see any questions in the chat, so thank you, presenters. This meeting is recorded and we're going to post it on YouTube sometime next week, and we'll post about it on Instagram and our newsletter when it's posted. Thank you, guys.
Thank you.
Thank you so much. That was really great.